Okay, this is a 7.2, number 17. We've got these two equations, y equals 7 minus 2x squared and y equals x squared plus 4. We want to find the area of the region between the two curves, so we need to sketch these. So how do we sketch such a thing? Well, first of all, let's take a look at equation number 1. Now this looks like it's a slender parabola, and it's shifted up 7. You could rewrite it like this: y equals negative 2x squared plus 7. So you see it's shaped like an N. It's a little more slender. And the intersection will be at 7, so we know it's going to intersect up here at 7. Do that in pencil just in case. So if I want to find out, kind of the general shape, we can find the zeros. So I can see what x equals when y is 0. Just set 0 equal to negative 2x squared plus 7. Then add that, so we get 2x squared, add 2x squared to both sides equals 7. Divide by 2, so x squared equals 7 over 2, which is 3.5. So x equals plus or minus the square root of 3.5. Well, we know that's a little bit less than 4, so the square root of 4 is 2, so it's going to be a little less than 2. So you can put your intercepts there. Something like that. And it's 7, so it looks something like this. So you can get a pretty decent sketch by just finding those zeros and approximating them. You don't have to. It doesn't have to be perfect. It's just a sketch to tell us what's going on. And the other one is just a regular parabola. It's shifted up 4, so it's going to look like this. So it's our standard parabola. So we want this area in here. And we can do it with respect to x and use little rectangles that are vertical rectangles like that. Now notice again, these are both even functions, so that the symmetry. So rather than go from this intersection point to this intersection point, which we need to find, we can just go from 0 to this intersection point and double it. So how do we find that intersection point, that point of intersection? Well, let's take a look here. And what we'll do is we'll just set this equation, x squared plus 4 equal to 7 minus 2x squared. And see if we can get a solution. Well, if I add 2x squared to both sides, I get 3x squared. If I subtract 4, that equals 3. If I divide by 3, I get x squared equals 1. So x equals plus or minus the square root of 1, which is just plus or minus 1. So that's nice. Looks like my sketch came out pretty good, too. So all I have to do is integrate from 0 to 1, and that's going to give me this area here, and then I just double it. So my area equals the integral from, and 2 times that, 2 times the integral from 0 to 1 of the top curve. Now what's the top curve? Again, this curve here is the top curve, and that's going to be the y equals 7 minus 2x squared. And this is the bottom curve here. And that's y equals, this top curve, and y equals x squared plus 4. That's the bottom curve. All right? So that's easy to see. I hope you can see that. All right? Top curve minus bottom curve. So that's going to be the integral of 7 minus 2x squared minus the bottom curve, which is x squared plus 4 dx. And there's your integral to find the area. Now we'll simplify all this as much as we can before we take the antiderivative. And this ends up being 7 minus 2x squared minus x squared minus 4 dx. Okay, and that area equals 2 times the integral from 0 to 1, and then that's going to be negative 3x squared, and then 7 minus 4 is plus 3 dx. And now we've got to simplify so we can take our antiderivatives. So area equals 2 times. And if I the antiderivative of this is going to be x cubed over 3, so those 3's are canceled. It'll be negative x cubed, which is nice, and then plus 3x. And we just want to evaluate that from 0 to 1, and the zeros are going to cancel out, so that's going to make that real nice. So 2 times, and if I put 1 in here, I've got negative 1, and plus 3, and that's just 3 minus 1 is 2, and 2 times 2 is 4, so that's my area. Okay, so that wasn't too bad. Again, make sure you know how to sketch these things and how to figure them out. That's why I spent a little time doing these. Kind of review that. Okay? And those are some basic pre-calculus ideas.